course schedule. Let's just copy paste this information. This should be good. Course schedule 2 question from Roblox. What was I gonna do? I was just gonna read the question, I think. So let's go through it. So there are a total of num courses you have to take, labeled from 0 to num courses -1. You're given an array of prerequisites, where prerequisites I is equal to AI BI, indicates that you must take course BI first if you want to take course AI. For example, the paired 0 and 1 indicates that to take course 0, you have to take course 1. Return the ordering of courses you should take to finish all courses. If there are many valid answers, return any of them. If it is impossible to finish all courses, return an empty array. Cool. Alright, and then, so imagine I wasn't given this information, right? I knew that fine order had parameters num courses being integers and prerequisites being like a list of integers. I'm just gonna like prerequisites, like a list of integers, and return a list of integers, maybe, and just writing boilerplate code, find orders, just to make it into the practice of this. I think LeetCode does like a beautiful job of giving us this code, but interviewers always like to throw us off and, you know, give us like nothing. So it's always best to prepare for the worst case. List integer. I think that's right. Find order. I forgot the self. I keep on forgetting the self. Now courses. Yeah, cool. All right. That looks correct. If it's not, it's going to stab me in the back later. Now we've kind of read the question. The next thing to do is, well, first of all, we know there are a total of num courses. You have to take labels from 0 to num courses -1. Yeah, okay. You are given an array of prerequisites. For prerequisites I is equal to AI BI, indicates that you must take course BI first if you want to take course thing. Wait, so that doesn't make much sense because AI, like, look, the pair is like this. Oh, I see. Like an element of prerequisites is like this. Okay, cool. Well, can prerequisites be empty? Like, what are the constraints on that? In AIBI, those can only be integers. And there are a total of num courses you have to take. Labeled from 0 to num courses -1. What does that mean? Labeled from 0 to num courses -1. And what is num courses? Like, what is the constraints on that? Oh, I guess like inside the prerequisites, this is what the courses would be. And so you need to like, well, I know this is a graph problem already, so I've kind of cheated, but I know there's some kind of a path going on where you kind of have to take a path and make sure it completes all the courses needed. Can we assume that if it is impossible to finish all courses, return an empty array? determine the ordering of courses you should take to finish all courses. Okay. Yeah, so I've kind of asked my questions. Number of courses, prerequisites, the size, what are the values inside. Can it be empty? I'm trying to think like duplicates. Can there be duplicate things? What else can there be? For example, the pair 0, 1, okay. And then if it's impossible, that either means there's not like num courses or there's no path that leads to it. Can we assume that num courses, that all num courses will be inside prerequisites, right? Like all the labels 0 to num courses -1 are in here. Like that's what I'm trying to determine right now. So let's see what the constraints are. So 1, okay. Through 2000, length could be 0. It could be num courses times num courses -1, okay. Each element in prerequisites is length of 2, okay. AIBI is going to be between 0 and num courses -1 inclusive. AI and BI are not going to be equal to each other. That's a good point. All the pairs AI and BI are distinct. Okay, cool. I was going to ask about duplicates. Cool. So I'm not going to label that down. I'm 6 minutes in right now. I've asked clarifying questions, but I haven't really gone through an example. Maybe I should, yeah, so I should get into the practice because LeetCode provides you with the example here. So I really need to like create examples before I even get into the clarifying questions. All right, so let's say we have num courses equal to 6, okay? And we're given an array prereqs, okay? And let's see, 2, 5, 1. So that's a problem because that's like a cycle, right? Because like to take 1, you need to take 2. To take 2, you need to take 5. And to take 5, you need to take 1. And it's just like loops. And the answer is list of integers. So if it's not in prereq, right? Like if this is not in prereq, and these are the only prereqs, can I, like, could my final answer be something like, so to take 1, I need to take 2, and then 5. So can I do like 5, 2, 1? And then be like a potential ordering could be 3, 4? Is that valid? I think that's a valid option. I'm curious. Let's look at the example just to make sure I got that right. But I mean, I wouldn't really have that opportunity in an actual interview though, so it's a good thing. That's something to keep in mind. Yeah, there's potential like correct orderings. All right, so I won't look at the examples any further. Let's brainstorm. Like, how would I do this as a human? So depending on num courses, I can really take them in any order, but prereqs defines an order for me. So I would, to take course BI, first you have to take course AI. Oh wait, hold on. So 1, 2, 2, 5. Oh, so it should actually be like this. My bad. 2, 5. And it doesn't matter where 3 and 4 goes. They can go really anywhere. 1, 2, 5. 3, 4. Potential answer. So as a human, I would like look through this list, and whatever kind of comes on the left, I would like add it, like 1. But imagine if one you needed to take 5 to take 1, right? So if you notice this kind of pattern, I would put like 5 in front. And then I would put like 2, 3, 4, doesn't really matter what else like whatever order I put in. Like that's like a key observation to make. What other potential like so I mentioned something like this. There can be nothing. And then you can just put it in any order you want. What's an invalid ordering? A cycle like this would be a problem because to take 1 you need to do 2, but to take 2 you need to do 1. So like, does 1 go first or does 2 go first? And since the direction is both ways, maybe that's invalid, maybe it's not. Well, you shouldn't have that scenario, but yeah. When it says distinct here, does it mean like distinct exactly, like 1, 2, 1, 2, or like 1, 2, 2, 1 is also good? Like what do you mean by distinct exactly? Yeah. Okay, well that's how I'm doing it as a human. I feel like that's way too simple though. Let's do like a longer example. Prereqs example. To take 3, you need to take 4. Something like that. So I would put 1 in because I need to take 1. But I notice 5 you need to take before you take 1. So just like put it beforehand. It's like a queue of sorts, or well, what if I need like what if I also need like this? I need to take 3 before I take 1, right? Then I also have to like push this in front. It's almost like a linked list of sorts. So I'm thinking about the data structures, but so that's how that would be, and then 5, 1, and then 3, 4. So I've taken 3, and I can now take 4. I can also take 2 anytime in the future as well. Like this is a potential answer. Just append it to the end, and what I'm seeing is like a double like linked list, right? Or Q maybe is kind of the implementation I see. Well, first of all, let's see if this were a list, this could be O n time. And being num courses, I believe. But actually it could be n squared because the length of prerequisites can be n squared because you gotta go through each one of them. Can you avoid that? Like having to go through each one of them? I don't know. Alright, so I'm at 15 minutes. I should have started coding like by around 12 minutes if I want to complete this by 25 minutes. I just don't know like what I'm supposed to be coding. Yeah, not really a great run through of this problem, to be honest. Let's move on to the graph explanation because this kind of part is not making much sense to me. But like, okay, so taking this example here, graphs, and we have this example. You know to take 1, you need to take 2. And we know to take take 3, you need to take 1. To take 5, you need to take 1. To take 2, you need to take 4 as well. So like this. Is that a good graph? It does point in that direction, like 1 points to 2, 3 points to 1 and 4, 5 points to 1. And then really this algorithm becomes a depth first search of sorts. Because you start with 1, go to 2, or should I flip this around? Like 1 is required by 3 and 5. And then like reverse the list. Because this is like 1 is required by 2. But then 3 is required by 1 and 5 is required by 1. How do I like, I want the arrows to be going like 5, 3, and then 1. Right now I'll be going like 1 and then 2. I did depth first search here. There's no depth first search. But this is a specific example too. Depth first search or breadth first search? I don't like the fact that I'm using the algorithms to guide my thinking. I want to be like thinking logically and then deciding what algorithm to use. Like you see what I mean? Like I want to be using my logic to guide the data structures and algorithms that I utilize. Not really trial and error like breadth first search or depth first search. That just, yeah. So this is one way of going about it, right? And I'm trying to create a path to complete all the different courses. Now, all the different courses don't necessarily need to be in here as well. And then, I guess, is checking the length of a list or a string, like, is that linear time as well? Checking the length of a string. I don't know. That's just a side question, really. Because I'm thinking if I convert this into a set, then it would avoid duplicates, like having like 5 from one time and 5 another time. And then if I could check the length of the string or the set and compare it with the number of courses, then I can see if I actually have a valid path or am I missing some courses, the crucial courses in there. Yeah, I'm at 20 minutes. I should be now reviewing, optimizing, and asking questions. Oh no. Alright, so I've done one way. The other way is what courses, like, so there's one here. What does one, like, what are prerequisites of 1, 5, and 3? Okay. Take 2. What are the prerequisites of 2? There are none. No, sorry. There is 1. What are the prerequisites of 3? There are no prerequisites of 3. What are the prerequisites of 4? 3. And what are the prerequisites of 5? There are none. Right? And now we can create a path 1 and then 5, 3. Right? And you kind of just go through each one. You go into 5 and 3. Like deep, right? Because you're trying to create this like link. And what this will do is like, so you come at 1. I'll create a link at 5. Okay. And if you go in and you realize like 5 is actually, a prerequisite of 5 is 3, then you actually like can grab 3 as well. But you'll realize 5 is nothing right now. Then you just move on to the next element, 3. You'll see 3 has no prerequisites, so it doesn't really matter. And then we just go down the list, right? 2. I think that is depth first search, right? You go as deep as possible, and then you move on to the next like stuff, right? Or is that breadth first search? Because then I want to do 2, right? I've already checked 1, so it's already visited, so I don't need to do that. And then 4, right? And then okay, so problem. Two has a prerequisite of 1. So how do I do this? I can like add it in front of 2. 3 has no prerequisites. 4 has a prerequisite of 3. It does? Yeah, a bit confusing to be honest. And then, okay, so if I do this way, 1. After 1 we need 2. And then what does 2 like? So does 2 have any? Is 2 the prerequisite of any courses? Right? So it's like the other way around, if you see what I mean. No? Okay, 3. It's a prerequisite of 1. Oh, that's so confusing. Because I'm like adding it, I'm not only adding it to the front, I'm also adding it to the back. Oh jeez, that is weird. Like I need a reference to this like node-ish thing. I'm thinking like a linked list of sorts is what's needed. Like a double linked list as well. Because that and 3 is dependent on 4, so I can just add it before 4. And what if like 5, like what if 5 is also another one, right? then it should actually be going like for like here. How do I delete this node right here? I have to, first of all, in the dictionary, we have this like adjacency list going on. Oh man, I got a confusing one. Like, first of all, we have, okay, we have a dictionary for, I'm 26 minutes in, oh my god, I should be over. I'm over time, oh no. But it's okay, let's keep on. So dictionary for the adjacency list. We have a dictionary for num course with specific node. What? Oh, we have a double linked list to represent the return type. We have to reverse this, right? Because 3, 4, then 5, then 1, then 2. Like what's the answer? Or hold on. Wait. So after 5, there's 3. So you have to take 3, then you can take 4, then you can take 5, then you can take 1, and then you can take 2. Yeah, because, yeah, that's fine. That's a potential answer. We have to reverse this result. Return type will be reversed though. Specific node and linked lists to keep track of positions. So that's a lot of stuff. Like this is a loaded. Yeah, it's loaded. But time complexity is still n squared. N being the length of being num courses. And space complexity also being n squared because you're holding the vertices plus the edges. So v plus e maybe? And I'm pretty sure that would be n squared. All right, so let's just try to code this up and see what happens. I'll give myself a solid like 7 minutes from here. So I am doing. So I'm going with this one, right? Or am I going with this one? I'm going with this one. Right, and I'm doing a depth first search. So first of all, we need a graph. Do I need to import this? From collections, import default dict. Pretty sure that's the right way to do it. And then we want to like be iterating through it. So while graph or like while man, it's tough. Oh my god. I'm just going up and down, up and down. Oh man. So we know we have this graph. And then, hold on, even before we do like a loop before the like in the graph, we have to do for prereq and prerequisites. You want to do graph. So one. So A prereq 0, B prereq 1. So B would append A like that. Okay. And then what? Well, graph, like does that work? Like should I call it on find order or? Oh man, I'm so bad at recursion too. Does while graph even work? And I guess I also have to define a linked list. I don't have that. Oh man, class linked list. Do I need like a def init self dot val? Next, none. Okay, and then self dot val is equal to val, self dot next is equal to next, and I think that's it, right? Self dot previous. We want a double linked list. And previous default values none as well, so double linked list. Pretty sure that's how you define it. And then, so I'll call it doubly, double linked list. Value next and previous. And while graph. Like, does while graph go through all the elements? Or am I just being dumb? Okay, well, let's assume it does do what we were expecting it to do. What's the expectation afterwards? The expectation is we are going through each of these adjacency lists. Let me just copy paste this. this will help me visualize. So we're going through each one of this. So we start with this one over here. For course in graph, first of all, we want doubly cur.doubly. We want cur.val equal to course. Okay. Then for prereq and graph course, which will lead on. Oh my god, oh my god, oh my. There we go. Yeah, so that will lead us to 5. And then we want to like recurse into it, see if 5 has anything else. Like if it had 3 and then had like a 2 and like all that stuff, then you'd want to do find order. But that doesn't feel right. Yeah, I feel like I can like put this in its own helper method and call that. Right, recurse on that rather than recurse on whatever. So first of all, doubly or cur.next is equal to prereq. Okay. Cur is equal to cur.next. Well. I should want something like this, right? Or doubly like this, foul. Next up, previous is cur, and then we just assign it to next, like that. And this doubly like this isn't really recurse. You don't want to really recurse on that. Like, but when you get into 5, then you want to potentially go to 3. So it's like this part that's recursing. Yeah, but this isn't recursing. It's this part. So def DFS. Oh, there we go. Okay. And then you want to graph will be the same. Course will be the same. Maybe this isn't what we want to go over as well. Maybe it's this portion that we want to wrap in the DFS. I'm at 40 minutes. Oh my. This is such a confusing way to write recursion. I am so lost. Oh my god. Of course, but like, I think you're understanding what I'm trying to do here, because graph force, prereq, prereq being 5, then you want to pass like prereq to here. Recurse on that, because then it's like, okay. Then it's like this portion here that you want to go over like 5 and do the exact same thing. So def graph course. No, but still something weird is going on. In the case that there's no prerequisites, in the case of 5 right here, it won't even run the slope, so it'll just like exit. That's fine. But this needs to change. Okay? Prereqs. And that's going to be a list of integers. What do you want to return from this? Nothing. You just want to like go through it. Alright, so you do this. Next dot previous is equal to cur dot next is equal to next. This sets the value up. We don't know what next will be right now, but cur is equal to cur dot next. And DFS prereq. Okay? So that's where we're setting it up. And now what about that third dictionary that we needed? Like, what if we get to a point? Well, I think it was like that scenario where we're doing 1, 5, like an example would be better. Where this scenario 1, 5, 3. And we gotta add something to the front, right? Or we want to add something in the middle here, like it's already here, for example, but what if we want to like remove that element and put it here? So we need a reference to that. And the way to do this is over here, we'll create a dictionary. and we'll call it course to node. Okay. Yeah, I don't know how to default dict. Maybe I can put in double list. I don't know. Maybe that's the thing. But here, course to node. Like course to node cur is equal to none. Or sorry, actually here, you wanted course is equal to cur. Okay? And then here, you wanted, this is such a convoluted mess, oh my. Next, sorry, prereq is equal to next. Okay. Yeah, it's 47 minutes. Do I even have the right output like going on? I don't. Like, okay, so I know the doubly is what I'm going to return. I know that's how you would usually do it for a list, but for a linked list, what I'm thinking is yeah, there's so many edge cases that I'm not considering here. Result.append. Yeah, like I gotta like traverse the linked list and everything and then append each element. You know what I mean? This is so wrong. But at this stage, the review optimized questions, yeah, like again, you optimizing, well, I don't know, questions. Well, yeah, I would just ask whatever questions I would to the interviewer. What does a successful candidate mean? Like this is just outside of like this technical problem. I didn't even think about edge like test cases in this question. Oh jeez, tough man. This was not easy. This was not easy at all. And then reviewing, right? Like going through this code and like making sure it's correct. Like, but again, that's when it's correct. When it's at this stage, they don't like. I don't think the interviewer knows what to do either. Like, there's so many syntax errors right now. Yeah, so many. Yo, man. Oh, I don't like this code. All right, so I'll leave it at that. I think I'm gonna like watch a video on it, understand, because I think 15 minutes is a good time to stop and try to understand what I'm lacking. Cool, but good learning experience. Yeah, I'll end it there.